says it makes an angle of 53.1 to the horizontal.
Yeah.
So like to the top of to the ground. With the ground. Oh, okay.
Yeah. Have you drawn it?
I'm opening the page.
Really bad to
I'll get the text here as well. Trigonometry. And then it's sine and cosine rules, isn't it? There we go. Okay, have you all had an attempt at drawing it? See? Yeah. Okay, so let's So let's have a look. Let's calculate now. What did I ask for? The height of the pole, was it?
The minimum distance between
The distance between the wires. I mean like the pegs on the ground. So if we look here, let's just zoom in.
Oh, the wire pegs. Oh, okay.
Can we see this okay? A telephone pole has two wires attached to it. Each wire is connected to the ground and also the top of the pole. The first wire is 15 meters long and makes an angle of 53.1, and the second wire is 13 meters long and makes an angle of 67.4. So we have here, here is the telephone pole, and then here's the ground, and then we have one wire, and what's the distance of it, did we say? 15 meters, and the angle is 53.1, and the other one is 13 meters,
67.4.
67.4, was it? Yeah. So I want to know minimum distance and then maximum distance. So actually, you know what? I think I'll just flip that around. I'll do the maximum one first. It'll be a little bit easier.
Meaning at the base and
At the base. At the base. So firstly, we want to get question.
What is the wires that are in condition?
Yeah, now that's the second half of the question. So you've spotted it, well done. There's two ways to look at this. We can draw it like this, or we could have put them both on the same side. Yeah, so what I'm doing first is this a case which is the maximum the two pegs can be apart. That's what I'm doing first. So, well, if I know this angle and this angle, I can know this angle. Can we get that, please? Got your calculator? I think I have mine.
59.5.
59.5, is it?
Yeah.
So I have cosine rule. If I call this x, I get x squared equals
15 squared.
15 squared. 13 squared plus twice 15, 13 cos 59.5. So this easily gives us the x. Yes? Hey Turkey, why are you late? Wait, why are you late?
We were eating our lunch.
That's a terrible reason to be late. Didn't you have an hour break for lunch?
Yeah, but we went to print homework.
Right, so what do we get for the x here? 24.3 meters. Now, as you saw earlier, there's a second way you could have done this. If I draw it again, or maybe I'll just use the same diagram, we could have had the wires on both sides, and this is 67.4 here. So if I just redraw that, it could have been like this. Here is 15, and then here is 13, and then it goes across here, and this angle is what was that one?
67.
The first one?
The
No.
first one is 59.3.1.
53.1, and the second one is,
67.4.
yeah, so that changes this angle. That's 180 minus 67.4. So that is 112.6, and that changed the angle on the inside, yeah. And this angle up here, 180 minus 53.1 minus 67.4, that makes the angle up here 15.
14.3.
Oh, I typed it in wrong. 14.3. So everything is the same except basically the angles change. So it's still, if I call this x, it's still x squared equals 15 squared plus 13 squared minus twice 15, 13 cos 14.3. So the only difference is here. In the second case, that is now a 14.3. So if I just go back on my calculator if possible, and then just change that angle to 14.3, we get 27.8, yeah. Wait, that's bigger,
Yeah.
but it should have been smaller.
Is it telling why?
Why?
Is it this-
Because look at the
Yeah,
picture.
yeah.
What?
Are we not counting that? Oh, we don't need the other angle? I mean, between
Wait,
the pole
either subtract.
In the formula, a squared equals b squared plus...
minus 2b.
Now you've got to have everybody confused now.
No,
A squared equals b squared plus c squared minus 2bc. Terrible.
Both
Right.
axes are wrong.
Minus there. Yeah, so both are wrong. Right, so... that's better. The second one is 4.01 meters, and then the first one is 14. Much better. 14 meters. Okay, that's more like it. Right, let's see what the next one is like. 14. Right, we'll do one more of these. The number 8 now. Okay. So it's a bit like the previous one, except there's now, it's 3 dimensions. Kinda, yeah. I'll draw what is happening here. So you have 3 superheroes, and they each have a rope, basically. And the first one is 19 away from B, and then B is 17 away from C. So if we were to look from the top, here's A, here's B, and here's C from the top. The A is 19 away from B, so this is 19 meters. And the B is 17 from C. That's 17. And they want to know what this is. So of course we don't have enough information yet. But we're also told that they each have a rope 26 meters long, and they're holding a helicopter in place which is 24 meters above the ground. So if I was to look at the side of it now,
Wait, I'm so sorry, but then for this question, how do you know that the A is in here, and then the B is here, and then the C is here?
that they're all lined up.
Yeah.
Oh yeah, I suppose. But
Why would that not be?
yeah, well, I suppose if they're all lined up like this, A, B, C, and they each have the same length rope, it's hard to imagine them.
Keeping a helicopter.
Like the people at the end's rope will need to be longer if they're to hold on to it. So they must be around it so that they all have a chance of holding on to it. I think what answers your question is the fact that they each have the same length of rope. Yeah. Okay. So I'm looking now, what you might call at the side here. So if you were looking at it at the side, each of the ropes here is, what did we say? 26 meters, and the helicopter is 24 meters above the ground. So I'll have to try and draw this a little bit three-dimensionally. If I zoom out a bit, okay, so right, this is my best three dimensions. That's already gone wrong. Right, try again. That's even worse. Hang on. I'll get it nice in 3D. There we go, okay. Right, so there's one guy here, one guy here, one guy here, and the helicopter's up here. So this is 24. No, the helicopter, yeah, 24, yeah. And they each have a rope. So there's one rope here, one rope here, and then one rope here. And these are all 26. Okay, so that's a 26, that's a 26, and that's a 26.
But we just said that 19 meters is being used, right?
The distance, now here,
okay,
this distance is 19, this distance is 17, and this is the distance I want.
So
Yeah.
why?
Is that okay? Can you see that? No, you're not happy. It's okay or not okay? Not okay? What part's not okay? Everything?
I was joking.
This is the picture for the story. Each superhero has a 26 meter rope. So that's there, there, and then there. And the helicopter, that's a helicopter, is 24 meters off the ground. Yeah. Now, what I'll do next is, if you can see here, I'll draw a line from here to here on the ground, and then from here to here, and then from here to here. So can you, again using your imagination, can you see that there's 3 right angle triangles in here? So the first one,
Are they right angles?
oh yeah, because I drew a perpendicular up to the helicopter. Its height is 24.
Oh, like that.
Yeah. So this one is 26 and this one's 24. And if I look at the next one, yeah, it's 26 and also 24. And the last one here is it's all the same. 26 and 24. So I can get the base, and what I've just shown is that all of these bases are the same. So square root 26 squared minus 24 squared, that's 10. 10, 10, and 10 then. So we have all the bases here, it's 10. 10, 10, and 10. So if I go back to my original triangle and I'm looking from the top, what I've done is I've drawn lines on the ground like this. One here, and one here. And these are all 10 now. 10, 10, and 10. So what I've done is I've made 3 isosceles triangles. These 2 angles are the same, and then these 2 will be the same, and then these 2 will be the same. I'm nearly finished. If I look at this triangle here, I have a 10 and I have a 10 and I want the x. So what would I love to know? I would love to know this angle here, and then I'd be finished. But I could know that if I knew this angle and this angle. And can I know these angles? Well, I can, because if that's a 10 and that's a 10 and that's a 19, we can use cosine rule to get this angle. We can use cosine rule to get this angle. Then we can subtract it from 360 and we got this angle. And if we got this angle, then we've got the x. So let's use the cosine rule here, and we'll call the angle, I don't know, we'll just call it A. So I can say 19 squared equals 10 squared
Minus 10 squared minus 10.
plus 10 squared minus twice tan 10 cos A. So after all of that calculation, I'll get A is 143.6 degrees. Now I'll go on to B. I'll do the same thing, except this time it's 17 squared equals 10 squared plus 10 squared minus twice 10 cos B. So I can get the B out from this. 17 squared minus 10 squared minus 10 squared divided by minus 2 times 10 times 10, and then cos inverse that. So I get B is 116.4 degrees. So now finally I can get this angle here, which is what I really want. So let me just draw the triangle again. 10, 10, x, and this angle here. 360 minus 143.6 minus 116.100, is it? Yeah, 100. So now I can get my x. So now I finally have x squared equals 10 squared plus 10 squared minus twice 10 cos 100. And then square root the answer, of course.
Yeah.
15.3. A very difficult question for sure. Very difficult question. If this ever came up on the test, they would break it down into parts for you. So for example, if this is an exam question, the first thing they would do...
Would they give you anything in terms of diagrams?
Yes, two things. If this is an exam question, number one, they'd give you a diagram, and number two, they'd break it down into parts. So for example, you know, they would give you this diagram, and then they might leave an X here in the diagram, and they could say, what's X? And you realise, well, it's just the Pythagoras one then, you know. And then they might give you this diagram, and they ask you for the angles here, you know. So they'll have it in parts. But even in parts, I still think in total maybe it's more difficult than what you could get in the exam. Because this question, you know, you'd almost have to do it in 3 or 4 parts, whereas in the exam they kind of keep it 2 to 3 parts. So I think it's a little bit too difficult for the exam. Did anybody actually get it? Yeah? No?
I agree with the structure.
That's as far as it went? Yeah, it's a hard one, alright.
But why did we not do anything, I mean, straight from that diagram?
Which one? This one?
Yeah.
This one established the tens,
Okay.
which was used in this diagram. Yeah. Okay, so what we'll do next, I said, is the equations. Yeah? Equations now. Where's the equations? Here they are. Right, let me just close this one down and this one down. Ah, come on. Equations, there we go. Now, if you're not trying these at home, that's your problem, because you're going to have an exam in a few weeks on everything from semester 1. So I don't know how much of this you did at home, but I don't feel like it was too much. It's just reality.
Is the exam?
That's what you signed up for. Right. I want to do the last two here, and then after I do these two, I'll do some graphs. Okay. You should have got them done because I asked you to do all of these, but let's have a look at this one, and then I'll give you a minute to try the last one. I'll give you a hint if you need a hint. So we have 2 cos squared 2x.
What number is that?
It's the second last question in the first one.
Oh.
Yeah. It's 2 cos squared 2x
minus 3 cos 2x
minus 3 cos 2x
plus 1.
plus 1 equals 0. You got this one? Yeah? Yeah. It's Q, yeah. Right. So first we can factorize. 2.
You can use like cos squared 2x as u, and then
Yeah, but life is short. Let's skip that step. Right, we have 2 cos 2x, and this has to be a 1, and it has to be a 1, and it has to be a 1, and it has to be a minus, and it has to be a minus, equals 0. So this gives us 2 answers. Cos 2x equals a half. Cos 2x equals 1. So using my calculator, I can type cos inverse a half, and I get 2x equals 60, or here I get 2x equals cos inverse 1, 0. How can I get the second answer here? 360 minus the first one. So the second answer here is 300, and the second answer here is 360. But I should have 4 answers.
Yeah.
So I add 360 again to make 2 more answers. So that would be 420 and 660. And here it'd be 360, which is actually the second answer again, and 720. But I also have to divide by 2. So I get x equals 30. Yeah, 150, 210, 330. Wait, hang on. 330, 0, 180, 180, and 360. Although, am I including 360? No, it's open at 360. So, and there's not. Oh, but I can fix it because I can subtract 360. But then, when I subtract 360, this becomes 0. So, it's actually a repeated answer, really.
And don't you fix it at the end?
Yeah, and this is the end. Yeah.
No, in the sense
So the answers are 0 in order: 30, 150, 180, 210, and 330. 1, 2, 3, 4, 5, 6. Yeah.
Do you always have to put it in order?
No. You wrote this one down? Yeah. Right, I'll let you try the next one before I do it. It's a little bit more difficult. The next one has a sine squared and it has a cos in it. And this isn't a quadratic. Because if it was a quadratic, what would this need to be if it was a quadratic? See, this isn't a quadratic right now. This would need to be cos squared and this would need to be cos to make the quadratic. So you might remember that I gave you a rule yesterday that says sine squared a plus cos squared a equals 1. So you can use this to change sine squared into cos squared or vice versa. So I'll just give you a minute to finish this one here. Try to do the last one there. I don't know if you're able to, but give it a go.
is the same.
It made the same equation, did it? Exactly the same.
Yeah. So then you get the
So then everything proceeds the same.
same.
Okay. Nathan, can you just read out what the original equation was?
Minus 2 sine squared 2x
Yeah,
minus 3 cos 2x
yeah.
plus 3 equals
So you can say that sine squared 2x
0.
equals 1 minus cos squared 2x. So if you put that in,
Minus 2
minus 2, 1 minus cos squared 2x minus 3 cos 2x plus 3 equals 0. Minus 2 plus 2 cos squared 2x minus 3 cos 2x plus 3. So that's 2 cos squared 2x minus 3 cos 2x plus 1 equals 0, which is exactly the same as the previous question. So now everything is the same, literally the same. It's exactly the same equation I made. So we know the answers. There they are right there. So these are the answers here for this one as well. So of course you don't need to rewrite it, it's the same problem. Graphs next now. No what? Previous?
No, where the question is
Oh, yeah.
number 4?
Number 4. This one?
Yes.
Okay. Can you read it out to me?
2
Okay.
tan
2?
Tan
Yeah.
open brackets
2x minus 1 minus 2.
Equals 0?
Yeah.
Right. Tan 2x minus 1 equals 1. Mhm. So then 2x minus 1 equals tan inverse 1. So 2x minus 1 equals pi over 4. Isn't it? Now, how do you get the second answer for tan? Do you remember? No, you add pi. Yeah.
Yes.
So the second answer is 5 pi over 4.
So why do we keep it in pi, not in the other version?
What are you asking
Why
me?
do- why
Can't
do
you
we-
see how tired I am? Are you really asking me a question, or are you just trying to tire me more?
No.
What is your question?
Why do we keep it in pi and not in degrees? Can we leave it in degrees?
What? Why? It's in radians. Now, why do I know it's in radians? Yeah. Why do I know it's in radians? Well, here. This isn't 1 degree, this is 1 radian because there's no circle on it. I warned you about that. You remember? I warned you. Oh, I heard that you liked the method Colin showed you for the units in biology. What do you mean what units? You were doing units with Colin last week, micro and milli.
Oh.
That was
Was it this week?
No, it's gonna teach us a better way.
He showed you another way to do it.
No.
He did. Are you sure?
Just the normal way, yeah.
And what? Did he?
yeah.
Classic Colin. Classic Colin.
Everyone
Right.
undermined you.
Yeah. Right, so it's radians. Are we happy that it's radians? Now, the problem here is the domain. So, is it limited from 0 to 2 pi? No, it extends in both directions. So, it means we have many, many answers because we can keep adding or subtracting 2 pi to make more or less answers. So, in fact, you can have 2x minus 1 equals pi over 4 plus 2n pi, because you can add it as many times as you want, because there's no limit now, it goes to infinity. And you can also do minus as well. And also you have 5 pi over 4 plus or minus 2n pi, where n could be minus as well. So to finish we have to add 1 radiant and divide by 2. So the x's could be pi over 4 plus 2n pi plus 1 over 2, or 5 pi over 4 plus 2n pi plus 1 over 2. And here your n's can be 0, plus or minus 1, plus or minus 2, etc. So you have infinite answers here. Not going to come up on the exam. That was a very hard one. I've never seen anything like this on the exam. They always limit the possible answers in the exam. Usually 0 to 2 pi, or sometimes 0 to pi. Yeah. This was a hard one for sure. Okay, we look at a graph one. Some people had a graph question they wanted to see. Yeah, which one is that now? We'll do that one. Let me open it up here. Graphs. Which one now? D. Okay, let's have a look at D. By the way, the graph question is easier this year than last year because they took something out of the syllabus. So previously there were 2 worksheets on graphs. In the past you used to have to draw the graph, but also you had to be able to work backwards from the graph to get the formula here. Just a little tricky. Let's have a look at D. Y equals sine, actually maybe Nathan you could just read it out there, sine, do you have it there? Yeah.
Sine
X plus pi over 4
Yeah.
3.
Plus 3. Right, so we have start, end, min, and max. 0, 360, no. 0 to pi, minus 1 and 1. Firstly, what's the A here? Capital A. 1. 1. Does anything happen?
Nothing.
Nothing happens.
Why do we keep
The B, what's the B here?
pi by 4?
No.
1.
1.
What? Yes.
1. Does anything happen?
No.
No. The C,
Pi by 4.
which does what?
It moves it pi by 4 units left.
To the left. So minus pi over 4. 7 over 8. 2, 4. 7 over 4? Yes. I know it is, but I'm tired. Right, and plus, and then these are unchanged. And then finally the D
3 units up.
moves it up. So this becomes 2 and 4. Right, so let's try and draw this graph now. We want the line at least level. Y, X, 1.
So isn't that minus 2?
What? No, it's not. It's plus 2.
Oh, that's right.
1, 2, 3, 4, 5, 6, 7, 8. Each of these are pi over 4 units. Minus pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. And the height goes up to 1, 2, 3, 4, and starts at 2, So if I make my box, we go down there, across at 1, across at 4, split this in quarters, 1, 2, 3, 4, so that's going to be 1 there, and then 1, 2, 3, so in the middle it would be about 2.5 here. So here, so the graph looks, oh wait, is it sine or cos? Sine, so it goes, oh, let's try that again. Like this. And then remember, this here is the axis. So if we just compare that with what's at the back, we are good. It starts here at about 3.5, goes up, down, up, reaching its lowest point is 2. So you can see here, it goes up at the start to the maximum, and then down to its lowest point. Oh, its lowest point is 2. Oh, sorry. 2, and I drew my green box here. Maybe I can fudge this. 2, 3. There.
Very long.
Nailed it. And then that's a 1 there. Okay. Yeah. Is there another one you wanted me to do as well? So what went wrong for you here?
I wrote +1.
I wrote the question then wrong. Yeah, that'll do it for sure. Is there another one to try?
The tan?
The tan one, yeah, the tan one's a bit weird. Let's have a look at it. Which one is the tan one now? Is the last one or something?
Well, yeah.
Yeah, the tan x. Well, we'll do the.
There's F over there as well.
Yeah, tan x minus 1. Was that it, or? Well, we'll just do tan x minus 1. So, tan x minus 1. Start, end, min, max. So for tan it starts at 0, kind of. It's hard, it's a bit weird, and ends at 180. If you remember, if the graph goes, like this.
Yeah.
Oh yeah, but I mean it continues on the left and the right, but this is the graph for tan. It's weird, I know. And what's the minimum?
Minus infinity.
Minus infinity, and the maximum?
Plus
Infinity. A, 1, nothing happens. B, 1, nothing happens. C, 1, or 0, nothing happens. D, minus 1.
Nothing will happen.
Nothing will happen.
Because it's no,
Goes down, but...
by how much?
Yeah.
So in fact it looks exactly like a tan x graph still. Nothing has changed. So it's still going to be like this. Shoots up to infinity at pi over 2, and then it comes from minus infinity back up to 0 at pi. And you cannot see the fact really that it's been shifted down
Because it's
1 unit, yeah, because it's infinity. Now,
just put infinity minus 1.
yeah, okay. Now it doesn't quite go through the origin here because its shape is a bit weird. When you shift it down, I think it gets knocked off a little bit. But this is a level of detail which I don't think they'll care about that in the exam. They've never ever asked the tan question in the exam because the graph is weird. They keep it to sine and cos. But I just think the finish will just have the computer program draw it. I think you might see some movement here if we have it in the computer program because it will be a bit smoother, the movement, so you can see the graph shifting down a little bit. But you won't notice it by much, I don't think. Yeah.
Steven,
Yeah.
like for the sign of cost, when you drew your answers, you had like so many things you left to write. When we're drawing ours, you know, the answer you gave
For what?
for the last question.
Yeah.
Mine, this one.
Yeah.
It was just like one, let me see, one period of one.
Oh yeah, so,
Yeah.
like I said,
One cycle.
you take out your ruler and you would measure the same boxes out again and again. And then it's just a matter of copying and pasting.
Do we have to do that?
No, but
The question
depends
wants
on
you to
your
go
domain.
past this, you do, yeah. Depends on the domain. I think for the homework, did I keep the domain always like 0 and 2 pi? I didn't say it, which I need to fix that in the worksheet, I should say it. But in the answer, yeah, it looks like I went from about minus 2 pi to 2 pi. Is it the same for all of them? No, actually, some of them are. I will fix that to include the domain in the question. Alright. Just to finish, what was it? Y equals tan x. Well, let's just do tan x.
Minus 1.
Yeah, but let's just do tan x first and then we'll put in the minus 1.
So it goes through there.
Yeah, well, this is just tan x.
Yeah.
It goes through 0. Now, when it shifts down a little bit, this gets pushed under. So you can imagine this getting shifted a bit under.
It doesn't pass through 0 anymore.
No, it doesn't, but it's not a major change. Well, no, I guess it'd be big. 1 unit is pretty big on this scale. If we zoom out a bit, yeah, now it won't be as noticeable.
Okay.
Yeah. So in blue, it's been moved down.
And it passes through minus 1.
No, not exactly.
What do you mean? No, it doesn't pass through here.
Yeah, I know.
But the scale goes to infinity to minus infinity. So, for example, if I went up in 20s, 20, 40, 60, 80, look what happens. Look, the difference becomes less noticeable as I change the scale.
The blue one is the correct one.
The thing is, in the question here, we know that we need to go to 4, don't we?
Yeah.
Because 4 is the maximum. But what's the maximum for tan? No maximum. So we can go up in any unit. So for example, if I went up in 100s, which I am allowed to do because there's no limit on it, then would you notice a movement downwards of 1?
No.
Not at a scale of 100 here. So this is what I mean, you can kind of fudge that fact at the end that it moved down a little bit by 1, and on an appropriate scale you can't even see the difference. Especially, this is just a freehand sketch, so I don't expect them to really care about that in the exam. But like I said, they've never asked tan x. Okay, so next week in the tutorial we'll have a look at whatever calculus questions come up from the new chapter then. Right.